Hi, I'm Sharad Garg, and I have over 15 years of experience implementing enterprise GIS workflows that involve significant field data collection activities. On our field data collection activities, we like to use an iPad to benefit from its user friendliness, but we also need a guaranteed repeatable sub-meter or sub-decimeter accuracy that is simply not possible by using an internal GPS on these iOS devices. Currently, there are no choices that would allow you to connect an existing mapping grade or survey grade GPS unit to an iPad. Therefore, there is no way to get the desired location accuracy while doing the data collection using an iPad. Thus, we came up with our own solution that would allow users to connect a professional grade, mapping grade, survey grade GPS unit that would provide a sub-meter or a sub-decimeter location accuracy while doing the data collection on an iPad. This is what we are talking about today. This is a Bluetooth product with a long-range Bluetooth capability that will connect into your serial device of your GPS and emit the data from a normal existing GPS device that you have, and will bring that data into an iPad. So in order to use this, it's very simple. You just plug into the DB9 port of your GPS and you power on the dongle and you connect using the Bluetooth. That's all you have to do. At that point, whatever the accuracy of this GPS device is the accuracy of the data that you're collecting on the iPad. Okay, so now let's see how this product works. In order to illustrate this, what I have here is on my left side of the screen, I have a GPS simulator to simulate GPS signals coming from an actual device. Obviously, we are indoors right now, so I'm going to use a simulator to simulate a GPS device. And on the right, you have my iPad screen that I'm sharing with the computer over Air Server. So as I mentioned before, this is strictly a hardware solution. There's no app running in the background. There's no app required to run to use this solution. This is strictly a hardware solution. So we'll just go into our settings. We'll go into our Bluetooth. It'll find our dongle, the Aman Enterprises NMEA Bluetooth dongle. We click on it to pair, and once the iOS device pairs with our dongle, then we'll be good to go. Let's validate that it is registered correctly into our system. This is correctly registered. It self-registers itself just by virtue of connecting. And now to demonstrate this functionality, we will launch just Apple Maps. Base Maps application installed on the iPad. It's correctly pointing out that I am in the greater San Diego area right now. So this is the internal Maps application showing the current location. What we'll do is now we will start the simulator to simulate our location, and you'll see that as soon as I start the simulator, my blue dot showing my current location in Washington now. If I change my GPS coordinate, it is actually overriding the internal GPS coordinate on the iPad. So I can feed it whatever coordinate and it will actually take the coordinate of the iPad. So all mapping applications that are relying on the internal coordinates will now be benefiting from this external GPS signal that is coming from your connected device via our dongle. Just to show you the actual data received, we have a helper utility function available. You don't need it in any way to use this solution. This is strictly for you to be able to see the data that is coming in, just as a GPS data viewer utility. You don't need it for functioning. It allows you to see your sky plot, your satellites, and it'll show you the number of satellites tracked and all that. It'll show you the raw GPS data coming through in the system. But again, you don't need to use it. I can just turn it off completely and you'll see that the solution is still working and it is continuing to override the internal GPS location. So in fact, at this point, if I was to go into find my iPad utility, it'll actually show that the iPad is actually in Ohio. So it's actually doing it at a very low level such that all location services that are offered by this device are benefiting from the higher accuracy GPS data that is coming through our dongle. So as you can see, we have a proof of concept working with a great product, which is strictly a hardware solution that will work across all iOS devices, iPhones, iPads, iPad minis, all alike, across all different iOS versions, across all different apps that you might be using to do the data collection. What we have today is we have been able to create a prototype unit, but this is not a waterproof version. So we are working today on creating a waterproof version of this product such that it is field ready for your use. And that's where we need your help with. We need your support to help us get to a waterproof enclosure offering the same type of functionality and the flexibility such that the professional GIS community can use the data collection capabilities of an iOS device, the user friendliness of an iOS device, and still have the quality of the data that is offered by a professional GPS device. So please help us by supporting our campaign. Thank you very much for your interest.